Hi, this is a lesson for Year 10 Higher Mathematicians. The topic is histograms, and this is Lesson 7, Histograms 1. Now, the grouped frequency table shows the wages of some employees at a company. A histogram has been drawn with wages on the x-axis plotted against frequency on the y-axis. Explain why this histogram is not a fair visual representation of the wages at the company. Well, at a glance, it would seem that the employees earning between £50,000 and £100,000, there's more of them than between 15 and 20,000. And we might think that because of the area of the bars. Similarly, you would say that almost looks as though there are double the number of people earning between 20 and 30,000 than 15 to 20,000 for the same reason, that the bar is twice the size. Now, the key with histograms is that it isn't actually fair because the class interval widths are unequal. And we have to find out a way of compensating for the fact that the class interval widths are unequal. And we do that by finding an average across the class interval. Okay, and that average is something called the frequency density. And to calculate the frequency density, we simply take the frequency for a particular class interval and we divide it by the class interval width. And what that does is find out an average across a particular group that allows us to compare one with another. So looking at this example, the grouped frequency table shows the wages in hundreds of thousands of some employees at a small company. Note the class interval widths are not equal. Draw a histogram, estimate the number of employees with wages under 16,000, over 28,000, and finally estimate the percentage of employees with wages between 22,000 and 50,000. Okay, so what we need to do to start off with is calculate this value of frequency density. Remember that frequency density is equal to frequency divided by the class interval width. So to start off with, it might make sense to find out what the class interval width is in each case. So from 0 to 15,000, okay, that tells us that the interval width of that group is going to be 15. From 15 to 20,000, 15 to 20 tells me the class width is 5. 20 to 30,000 means the class width is going to be 10. 30 to 50,000 means the class width is going to be 20. And finally, here the class interval width is going to be 50. Now that we've calculated the class interval width, we can calculate the frequency density. Frequency divided by the class interval width. So here we're going to have 7 divided by 5, which is equal to 1.4. Okay, which means the frequency density for this this group is 1.4 compared with the frequency density for this group, which is 0.2. And we do that for each group in turn. 7 divided by 10 is equal to 0.7. 2 divided by 20 is equal to 0.1, and 1 divided by 50 is equal to 0.02. So we have now found the frequency densities for each of these groups here. Now we need to turn those into a histogram. So here are the axes, frequency density on the y-axis and wages in thousands on the x-axis. And remember that the class intervals widths are not the same. So you are going to expect to see the bars are going to be different widths. But what is key, the key difference between this and the histogram we saw at the start, is that this one is going to have the frequency density representing the height of the bars. That means that it's an average across that group. It makes it much easier to compare one group with another. So we've got the one drawn here. This is 0 to 15,000 with a frequency density of 0.2. The next one is 15 to 20,000 with a frequency density of 1.4. $20 to 30,000 has a frequency density of 0.7. $30 to 50,000 has a frequency density of 0.1. And finally, 50 to 100,000 has a frequency density of 0.02. So it's only a tiny thin slither here at the bottom there for that one. And as you can see now, although the class intervals are all different widths here, it's much clearer this time that by calculating this frequency density, the average across the particular groups, we can see that the people who are, or the most common wage earned at this company is between 15 and 20,000. Okay, compared with the others. Now what we're going to do next is use this histogram to help answer some questions involving estimations about the number of employees earning under and over certain amounts of money. And key to this is understanding that if the frequency density is equal to the frequency divided by the class interval width, then the frequency density multiplied by the class interval width must be equal to the frequency for a particular class interval. And what does that mean in terms of the histogram? Well, if we multiply the frequency density here by the class interval width, what we're effectively doing is finding the area of a particular bar. In other words, the area of the bar represents the frequency for a particular class interval. Okay, and we're going to use that to help us solve the first problem here, okay, which is asking us to find or to estimate the number of employees with wages under £16,000. So where is 16,000? Okay, on here, our 16,000 is represented okay, by that line there. So in other words, everyone earning under 16,000 must be these people here, plus these thin sliver down here, like so. Now we know that if we find the area of these bars, okay, that is going to allow me to come up with an estimate for the number of employees earning under 16,000. So here we go then. If we do this first one, which is going to be 15 times by 0.2 plus, and this is here, remember it says 15 to 16,000, so the width of that particular highlighted bar is going to be just 1 times by the frequency density, which is 1.4. If I type that into a calculator, I should get out the other end, that is 4.4 employees who are earning between who are earning under £16,000. Right, for C, we're asked to look at employees who are earning over £28,000. So again, let's go back to our bar chart here. 20, 30, so 28 is going to be here. Right, now in actual fact we can save ourselves a little bit of time here, okay, because we already know from the table at the start that this here represents 2 people, a frequency of 2 people, and this here represents a frequency of 1 people. What we want to know is what frequency is represented by this thin strip here. Okay, so all we need to do for that is the width of this bar here, which is 2, times by the frequency density, which is 0.7, add the 2, add the 1 person here, and that should give me, again, 4.4 employees, and that is just coincidence, all right, that number happens to be the same as for B. Now finally, for D, we want to find the number of employees earning between £22,000 and £50,000. So what we're going to do for that one then is okay, for that, what we've got to do for that one is between 22,000 and 50,000 implies it's going to have to be between 22,000 and 30,000, which is a width of 8, times by the frequency density of 0.7, plus the 2 people who are between 30 and 50,000, which actually gives us 7.6 employees earning between 22,000 and £50,000. Then we just need to turn that into a percentage. 7.6 divided by the total number of employees, which is actually 20, and multiply by 100, which gives me 38% of employees earning between £22,000 and £50,000.